Substitution method. This is one method used to solve systems of equations. Step 1. Solve either equation for x or y. You want to try to choose the variable with a 1 as a coefficient. Step 2. Substitute into the opposite equation for the variable you just solved for in step 1. Step 3. Solve the equation. If you get an answer, proceed to step 4. Step 4. Take your answer from step 3 and substitute it into step 1. Your solution is the intersection of the lines if they were graphed. On step 3, if the variable drops out and the numbers left do not equal, then the lines are parallel and there's no solution. Parallel lines are also inconsistent lines. If the variable drops out and the numbers left are equal, then the lines are the same line and there are infinite solutions. Same lines are called consistent and dependent. If you do get a solution from step 4, the intersecting lines are also called consistent and independent. Down here you can see I just made a quick graph of intersecting lines, one solution, consistent and independent, same lines, infinite solutions, consistent and dependent, parallel lines, no solution, inconsistent. Here's the first example. X plus 4y equals minus 10, minus x minus 3y equals 9. From step 1, I'm going to take the first equation and solve it for x. I'm choosing the first equation for x because the coefficient in this first variable here is a positive 1, and that's the easiest one to solve for. So I rewrote it over here. X plus 4y equals minus 10. Subtract 4y from both sides, and I end up with x equals minus 10 minus 4y. It doesn't matter which way you write this here because you're just going to substitute it. So since I solved the first equation, this answer here for x needs to get substituted into the second equation. So I rewrote the second equation, minus x minus 3y equals 9. And now instead of this x, I'm going to put in minus 10 minus 4y, and I'm always going to put it around parentheses when I make the substitution. This negative on the outside stays because that was in the original equation. And here, instead of x, I put minus 10 minus 4y, minus 3y, that's the rest of it, equals 9, and there's my 9. Now I solve this. Distribute the negative sign, so this becomes a positive 10. Negative and negative is a positive 4y. Minus 3y equals 9. Combine like terms. 4y take away 3y is 1y, so 10 plus y equals 9. Subtract the 10 from both sides now, because remember I'm solving for y, so I get y is a minus 1. So I did get a solution here. So if I was looking at my steps, solve the equation. If you get an answer, proceed to step 4. That's right here. These conditions do not apply. I'll do those at the end. But I pretty much go right down here to step 4 and plug it back in. So I take the y is 1. I'm going to bring it all the way back to here. And I'm going to insert a negative 1 for y right here. So minus 10 minus 4 times a minus 1. That's my x. Minus 10, so distribute this, you get a positive 4 as an x. Negative 10 plus 4 is negative 6, x equals negative 6. Notice I just switched the two things on the equation. It's okay if you switch them as long as you switch both of them. So the solution here in the form of xy is minus 6 minus 1. Again, if I was to graph this, this would be the intersecting point. And another way to talk about this is that they're consistent and independent. Let's try another one. Minus 2x minus y equals minus 13. X minus 2y equals 9. This time I'm going to choose the second equation and solve it for x because there's my positive 1 on the x coefficient. So I rewrote it here. X minus 2y equals 9. Add the 2y to both sides, and I get x equals 9 plus 2y. I'm going to take the value for x and plug it into the opposite equation, which is right here, the minus 2x minus y equals minus 13. I rewrote it down here. So instead of this x, I'm going to put my substitution 9 plus 2y, which is right here. So minus 2 parentheses 9 plus 2y minus y equals minus 13. Distribute the minus 2, so I get negative 18 minus 4y minus y equals minus 13. Combine your like terms. 18 minus 5y equals minus 13. Add 18 to both sides. Minus 5y equals 5. Negative 13 plus 18 is 5. Divide by minus 5. So I get y equals a minus 1. Again, I got a solution. So I go back to here and I put a minus 1 right where I have my y. So x equals 9 plus 2 times a minus 1, or 9 minus 2, so x is a 7. And again, I got a solution, 7 minus 1. It's consistent and independent. So these lines do have an intersection. Let's try another one. 8a plus 2b equals 18. 4a minus 3b equals minus 15. This one is not as easy as the other two, as I do not have a 1 as a coefficient on either variable. So usually what I want to look for is things that will divide out equally, and I noticed that this 2 will divide into the 8 and the 18, so I'm going to solve the first equation, or equation 1, for b. So I rewrote it. 8a plus 2b equals 18. Subtract the 8a, so I get 2b is equal to 18 minus 8a. Finally, I divide by 2, so I get b is equal to 9 minus 4a. So 18 divided by 2 is 9. 8 divided by 2 is 4. Now I'm going to take what I got for b and put it into the second equation. Remember, it's always the opposite equation for b. So 4a minus 3 parentheses, always put it in parentheses, 9 minus 4a equals minus 15. Distribute the negative 3, so I get 4a, negative 3 times 9 is negative 27, negative 3 times negative 4a is plus 12a, equals negative 15. Combine like terms. 4a and 12a is 16a. Minus 27 equals minus 15. Add the 27 to both sides. So I get 16a equals 12. So negative 15 plus 27 is 12. Divide by 16. And I get a is 12/16, or when I reduce that, 3/4. So I did get a solution, even though it's a fraction. It's still a solution. So I go back and I put it in for a up here. So b is going to be 9 minus 4 times 3/4. So 9 minus 4 over 1 times 3 over 4. 9 minus, when you multiply fractions, multiply the numerators, multiply the denominators. So 4 times 3 is 12. 1 times 4 is 4. 12 divided by 4 divides out to a 3. So it becomes 9 minus 3, or 6. And again, my solution is in the form AB. A is first here, B is second. So that's usually the way you write them, AB. And it's 3/4 and a 6. Again, it's consistent and independent. Let's try ones that don't work. X minus y equals 6. 3x minus 3y equals 10. So again, I'm looking for the variable that has a 1 as a coefficient, which is the first equation right here for x. So I'm going to solve the first equation for x. So x minus y equals 6. Add the y to both sides, so I get x equals 6 plus y. This is going to get substituted into the second equation for x in parentheses. So 3 parentheses 6 plus y, make sure you rewrite the rest of it, minus 3y equals 10. Distribute the 3, so you get 18 plus 3y minus 3y equals 10. And all of a sudden, when you get to this step to combine like terms, the 3y subtracting the 3y cancels out, and you get 18 equals 10. So these two numbers do not equal each other. There's no solution. They're parallel lines. They're inconsistent. So if I quickly scroll back to the instructions, if the variable drops out and the numbers left do not equal, then the lines are parallel and there's no solution. So that's what happens when the variables drop out. That's what it looks like. All right, let's try the last one. 9x plus 6y equals 15, minus 3x minus 2y equals minus 5. I'm going to solve the second equation for y. Nothing divides out equally. I'm just going to pick the smallest number, so I decided to do this one for y. So 3x minus 2y equals minus 5. Add 3x. Got minus 2y equals minus 5 plus 3x. Divide by a negative 2. So I get y equals positive 5 halves minus a 3 halves x. Since I solved the second equation right here, I need to get back to the first equation. So where this y is, I'm going to insert 5 halves minus 3 halves x. So I'm going to have 9x, there's my 9x, plus 6 parentheses 5 halves minus 3 halves x, close the parentheses, equals 15. So 9x plus, I distribute the 6, so 6 over 1 times 5 halves, minus from here, 6 over 1 times 3 halves x equals 15. Multiply numerators, multiply denominators, so I get 9x plus 6 times 5 is 30, 1 times 2 is 2, minus 6 times 3 is 18, 1 times 2 is 2, that's still an x, don't lose anything, equals 15. 9x plus 15, 30 divided by 2 is 15, minus 18 divided by 2 is 9x equals 15. Finally, when you get to this point to combine like terms, the 9x subtracts out with the 9x, but this time you get 15 equals 15. This is the same line, infinite solutions. That means it's consistent and dependent.